It's the only thing that slowly stops the ache. But it's made of all the things I have to take. Jesus never ends. It works its way inside. If the pain goes on. Collapsed, I've waited as my time's elapsed. Now all I do is live with so much fate. I've wished for this, I've bitched at that. I've left behind this little fact: you cannot kill what you did not create. I've gotta say what I've gotta say, and then I swear I'll go away, but I can't promise you'll enjoy the noise. I guess I'll save the best for last. My future seems like one big past. You're left with me cause you left me no choice. I push my fingers until
You know, when you work on a mission this long, it feels like a part of you. I've been a space enthusiast since I was 4 years old. Getting to work on a mission like this it's a dream come true. To me, Dawn is truly Earth's first interplanetary spaceship. No other spacecraft has gone to a distant body, gone into orbit around it, maneuvered there, then broken out of orbit, traveled elsewhere in the solar system to another alien world, and gone into orbit around it. And it does that with ion propulsion, which I first heard of in a Star Trek episode. We've turned ion propulsion from science fiction into science fact.
The Dawn mission really is a journey back to the beginning of the solar system, and that's why we call it Dawn. We chose 2 time capsules from the beginning of the solar system, Vesta and Ceres, which are the most massive and largest bodies in the main asteroid belt. They both formed very early when the solar system was forming out of the protoplanetary disk, and yet they ended up in these 2 very different states. Vesta is a dry, rocky body that looks a lot like our moon, whereas Ceres had a lot of water, and it looks much more like the icy moons of the outer solar system.
And it seems like what determined their eventual fate was the location where they started. And we now believe that Ceres formed much farther from the sun than it is now.
When Dawn found the bright material on Ceres, what we saw was completely mind-blowing. It was made of sodium carbonate. Sodium carbonate is not common in the solar system, but we see it coming out of the plumes of Enceladus. We see it in lakes on Earth, and here it was on the surface of Ceres.
The mission will end when Dawn runs out of the conventional chemical propellant that it uses to orient itself in the zero gravity of space. Dawn will become this inert celestial monument in orbit around the dwarf planet that it unveiled. Dawn serves as a lasting reminder that the passion for bold adventures and our noble aspirations to reach out into the cosmos take us far, far beyond the confines of our humble home here on planet Earth.
On November 12th at 7:35 Pacific time, a lander will land on a comet. This is one of the hardest things that has ever been done by the human species.
So NASA's role in the mission is sort of as the junior partner?
The spacecraft was built by the European Space Agency. NASA contributed 3 instruments.
Along with backup support with what we call the telemetry, how you're going to track it, navigation.
American instruments will operate on board of the mothership. And the mothership is really the main part of the mission. It will follow the comet all the way around the sun. We'll learn amazing amount of information about a comet. Comets are like little refrigerators floating out there, far away. They were far away from the sun, and they froze all these early particles.
They were frozen, solid remnants from the forming solar system.
Most of the scientists agree that the water, or at least most of the water on Earth, came from comets. So you showered in a comet this morning. It's extremely difficult to land on a comet. This is an absolute first for humanity. The comet is moving about 35,000 miles an hour. Unbelievably difficult terrain. There are about 58 boulders on the site where it lands. There are jets shooting out of a comet. Very difficult situation. We kind of describe the situation as the lander being a cherry on the top of the cake.
We've been waiting for this for more than 10 years, 20 years, and it's hard to really even think that it's really going to happen.
Actually work with oxygen and nitrogen found at those altitudes. Now, the press release very specifically talks about how they tested this system in a vacuum chamber. Initially, they started by flowing in xenon at the velocities and densities expected at this altitude, and they were able to get the thruster to fire. Then, after some work, they were able to switch over to oxygen and nitrogen. And the engineers say that the moment they knew that this was working was when the colour of the exhaust changed from the brilliant blue of the xenon to the purple of the oxygen and nitrogen. Now, it's worth talking a little more about the details of this air intake system. So first of all, when you are operating an air intake on Earth, you can essentially treat the atmosphere as a fluid. But as you go higher and higher up, the individual particles in the gas, they start to travel longer and longer distances before they bounce off each other. So at the altitudes they were working at, they were dealing with mean-free paths, that is the distance between particle collisions, that could be measured as high as a meter or so. So if their intake was of this size, so it's entirely possible that the particles would come in and bounce off the intake and then bounce back out and not meet anything else. So it actually requires a lot of careful design to take this very rarefied particle stream and then slow it down and turn it into a fluid at sufficient pressure that they can feed these engines. At 250 kilometers up, we are still relatively deeply inside the atmosphere, and most of the molecules are not ionized, so you can't use electromagnetic means to slow down the particles without touching them. But most studies estimate that collection efficiencies might be as high as 40%. And that capture efficiency is important because regardless of whether it gets captured or not, it generates drag. So as the capture efficiency drops, the exhaust velocity has to get higher and higher to balance out the drag. The exhaust velocities required are measured in tens of kilometers per second, which pretty much means no chemical thrusters will work, but there are a whole plethora of electrical systems which work just fine. Ion thrusters, Hall effect thrusters, and even things like pulsed plasma thrusters. All of them have their pros and cons, but to me it looks like the one they are demonstrating is a Hall effect thruster, which I believe was being investigated by the University of Toulouse, so that would line up with ESA doing this. Now, what's also not clear is there an intermediate tank? Is that required? Because some designs of engines will require a minimum flow rate before they can start firing, and if the intake is unable to provide that at the atmosphere they're working at, then they would need to have some sort of accumulator and release system. Similarly, I have questions about what kind of power is required for this. Because again, if you remember, if you're at low altitude and you're using solar panels, then those inevitably add drag. The concept art does take account of this and shows a spacecraft covered with solar panels, but not with any extending out into space like giant sails. Also, the design will need batteries because they're going to have to operate this in the day and the night side of the planet. If you only fired the engines when you were on the daytime side, then what would inevitably happen would be that on the night side, the apogee would rise, and on the daytime side, the perigee would drop until the spacecraft eventually couldn't maintain altitude. Another interesting question is how low can this operate at? Because as you get lower down, obviously you get more and more air to propel yourself, and you have to use all that to offset the incoming drag. But that then means you need more and more electrical power, which means more and more solar panels. So there is probably a point at which the amount of solar panels you have to add is offset by the amount of drag that they bring, and you end up reaching a lowest ceiling before you start to decay. There's also the question of the long-term operation of these thrusters when you account for the chemical effects. Now, electrical thrusters frequently operate using noble gases because their reaction rate is practically zero. Oxygen and nitrogen ions are, however, much more reactive. Indeed, these atoms are frequently found as core components of rocket fuels. So repeated contact by these highly active chemicals with the walls of the electrical thrusters could lead to long-term degradation, and so far I haven't seen any details on this from the design team. So obviously this is very cool because it opens up a whole new regime of space where satellites could operate for long periods of time. But simultaneously, the details are kind of vague, and I'll be looking out for the more technical publication at some point. I'm Scott Manley. Fly safe.
There's an asteroid discovered in December 2004 called Apophis, named for the Egyptian god of death and darkness. It was named only after its trajectory was identified to intersect that of Earth. Had that not been the case, we would not have named it Apophis. Could name it like Tiffany or something, or Bambi. You know, something not threatening. This one was headed towards Earth, Apophis. All right. Once you discover an asteroid, you got to wait a little while to get enough of a segment of its orbit to calculate what the full orbit will be to know if it will come in harm's way. So, we did that. We, the community. I wasn't the one. We got peeps who do this, okay? So, peeps, if you're over 30, means people, okay? Forgive me. If I say you got peeps, it's people. It's actually a loving phrase, right?
It's not little yellow marshmallow.
They're not, no. Right. So, we get the orbit. Turns out, in the year 2029, the month of April, the 13th of April, a Friday, Apophis will come so close to Earth that it will dip below our orbiting communication satellites. And it is the size of the Rose Bowl. It'll be the largest, closest thing we have ever observed to come by Earth. Now, of course, a much bigger asteroid took out the dinosaurs, but we weren't around at the time. So this is in the era of observing the cosmos with technology. This will be the closest, biggest thing we'll ever see come by. Now, the orbit we now have for it is uncertain enough, because these things are hard to measure and hard to get an exact distance for. The orbit is uncertain enough, so we cannot tell you exactly where that trajectory will be. We know it won't hit Earth. We know it'll be closer than the orbiting satellites. There is a range, a 600-mile zone. We call it the keyhole. If the asteroid goes through the middle of that keyhole, it will hit the Earth 13 years later. It will hit the Earth. 500 kilometers due west of Santa Monica.
So it doesn't matter where it goes through that keyhole.
Now, that's if it goes through the center. If it goes through other places within that keyhole, then the contact point shifts further into the Pacific or closer towards
Las
North
Vegas or
America.
something, yeah.
Yes. okay? But if it goes through the center, it hits the Pacific Ocean, plunges down into the Pacific to a depth of 3 miles, at which point it explodes, cavitating the Pacific in a hole that's 3 miles wide, 3 miles deep. That will send a tsunami wave outward from that location. That's 50 feet high, 5 stories. Oceans don't like having holes in them. So, this 3 mile high wall does what? You say that so timidly, sir. Collapses. It's a 3 mile high wall of water. Thank you. Falls back into the hole, sloshing against itself with such ferocity that it rises high into the atmosphere and falls back down to the ocean, cavitating the ocean again. So now you make a cavity a second time. This cycle takes about 50 seconds. You can calculate it, okay? So here comes the first tsunami, and 50 seconds later comes another tsunami. So there you are on the beaches of Malibu. Tsunami comes in. Now, unlike the tsunami in Indonesia, which was one wave that went deep into the shore, this first wave needs a supply of water to exist, so that the next wave actually sucks back on it to create itself. So, this tsunami will only go in about 1/4 mile. We have the sound effects person in the upper row there. So it only goes in 1/4 mile before it gets sucked back out for the next wave to come. Here's the problem. Whatever was there on the coastline is now brought back out to sea. And the next tsunami brings it back to the shore. All the $1 million homes in Malibu, they get taken out to the sea and then back. But this time they're in a slightly different shape, okay? And so what happens is all the artificial stuff, all the houses, the factories, they get churned into this ablative force that sandblasts the entire west coast of North America clean. So have a nice day for that.
But this begs. So
I'm sorry, I said 13 years after 2020. I misspoke. It's April 13th, 2029, and if it threads the keel, it will hit Earth April 13th, 2036. So it's a 7-year.
Back in November 28, 2013, as Comet Misison was approaching the sun. Now, many people thought it was going to hit the sun, and we waited until it appeared out the other side, and it had disintegrated into what we call a meteor shower. It's probably the only recording of how a meteor shower forms. Now, when it comes, notice also the electrical connection between the sun and the comet. They're opposite polarities. It's an electric universe. They were throwing out extremely powerful solar flares and coronal mass ejections that stripped the tail off of it. But each of those arms in that V spread out for 20 million miles. At the same time, Comet Encke was being seen on the satellites. Now, it disintegrated like that a long time ago. They have calculated that this comet, 2P Encke, is responsible for most of all of the meteor showers. As it has come around the sun at different times, it must have been huge originally, or this is the remnants of something even larger. but they can go back and trace the different meteor showers that we go through, and Encke is responsible for, I think, almost all of them. Now, the way that it crosses, and you notice your timestamp, I started it as of today, it has about a 3.3 year orbital period. Now, it comes just outside the orbit of Mercury, the closest planet, then goes back almost out to Jupiter, which is the orange line, and then comes back in. Now, what it's left over the years is the exact trail of the Taurid meteor showers. Notice that as it went in, it crossed the planet's path of Earth, and as it came back out. So you got the June Taurids and you got the November Taurids. We go through 2 of these a year. Now, they're saying that Taurid stream is a bit tricky to visualize in this report, guys, and I have a point for doing all this. But that's why I showed you the elliptical path of Comet Encke, because they follow that path because they are part of the debris trail. Now let's get into kind of more of the meat of this video. Going back to June 30th, 1908, many of you are aware of it, probably every one of you, of the Tunguska event. It happened above Siberia. It says an object the size of an apartment building came hurling out of the sky and exploded in the atmosphere above there. The Tunguska event, named for a river flattened trees for 800 square miles. Now, it occurred in one of the least populated places in Asia. The Tunguska airburst stands as the most powerful impact event in recorded human history. Now, this is modern recorded history, and it remains enigmatic as scientists don't know the origin of the object or whether it was an asteroid or comet. But guys, they're estimating now that it was one of the June or Beta Taurids because of the date and the direction of the tree fall. As they looked at those old pictures, and they determined again that's the same angle as the Taurid June meteor showers, the Betas. Now look at the bottom paragraph. Some years Earth passes near the densest cluster of material in the Taurid stream. And 2019 will be such a year. The scientists say it presents potentially the richest batch of incoming material since 1975. It says when there was a record spike in impacts on the moon during the Taurid shower. Some of the most spectacular fireballs come from the Taurids. It's not the most, but some of them are very large. Now in this article it says that NASA's JPL, through NEOCAM, which is an infrared space telescope, they've identified more than 90% of the objects that are large enough to cause a global scale disaster. Now, they're not saying any of these are supposed to hit the Earth anytime soon, but we're not talking global scale in what we are looking at. Now, this possibly has happened about 12,000 years ago, but it says, but moving down the scale size, the census is far spottier. Only about 30% of medium-sized objects, 140 meters, 460 feet in diameter or larger, have been spotted. And the lady Amy Manzer said that only about 1% of objects have been found that are the size of the Tunguska impactor. 1% have been found, which was about 40 meters, 130 feet in diameter. She said she welcomed the idea of a special effort to look for objects during the Taurid swarm in June. So they are watching this event, guys. That's why I'm doing it, because of the June warning that we're going through a thicker part. Now, if you look at this and you go back through history, there are several points that indicate that this is what happened in the cataclysmic event on Earth 12,000 years ago that wiped out the woolly mammoths. And again, I've talked about that in videos for the last few years, and we'll take a look at that. But remember, 140 meters, 460 feet. Now remember, 460 feet for the 30%, the 1% like Tunguska, 130 feet wide rocks was estimated. Now this information on Encke, and it talks about one of the objects inside of it right here. It's part of the meteor storm. It's near-Earth object 2045. This thing is estimated to be, by the Infrared Survey Explorer, or NASA's Wide Field NEOWISE, 1.36 kilometers, guys. That's 0.81, almost 8.9 miles wide, not 130 feet. So there are large objects inside this meteor storm. And I just wanted to point it out. It's not a fear-mongering video. Now let's go back 12,000 years ago and let's look at some places around the planet that received tremendous damage. Possibly it ended the period of the woolly mammoth. But these are the Carolina bays along the eastern shores of the U.S. And they have traced back all of these millions of impacts to two places where they struck. Again, I've done videos called the Carolina Bay series. And across the U.S., once they struck in the large ice cap that covered the upper U.S., it created all the impact points. Some of them are full of water, but these that you don't see are from infrared imaging, and they're in the fields and some of the, it's all across the area, but you can tell the impact points, and if they trace back from where the high point is, from where the mud was pushed up on one side, they trace them back again from Canada to the northern U.S., different impact zones all through here as we came through some type of meteor shower. The Algonquin Native American tribe, guys, has a legend that goes back 12,000 years ago. They've been here a long time, that they watched a meteor shower approach. They bury themselves in the rivers, in the mud, the ones that survive, and they watched the impact as the top of the mountains and the giant trees burned, and they said it killed all the large animals. And then they watched it, part of it that didn't impact the earth, retreat back into space. Now, Brian Forster, he's done series about this around the world 12,000 years ago. Remember Puma Punka in Bolivia? Destruction. Same time. 12,000 years ago as the Carolina Bays in the U.S. Here in the Nile Delta of Egypt, also Brian Forster, talking about the destruction that occurred at that time. And it leads not only there, but you go to Lebanon, Baalbek. There was utter destruction there, and this was not done by the Romans. This is ancient megalithic structure that was one of the landing zones besides Mount Hermon that the fallen angels are in the Anunnaki Sumerian text. That group of Marduk and his men that came in and kidnapped the earth women and married them. They were going to kill everybody if they didn't let them do it. They had the technology then, but there was heat that blasted through these areas. Wasn't just impact. This is the Sun Temple, I think, there in Baalbek. Ancient work. The top part was Roman. The bottom part was way older than that. And the way that these rocks, and again, this is 12,000 years ago, Peru, Brian Forster, they explain that the only way rocks flake like this is being exposed to extreme heat or high blast. It's not natural corrosion. That heat peels off the layers of the stone that were exposed. And in that video, you can see the other side of the building was flat. Now, this is one of the torrids that came in November. And again, in June, they will have some of the large ones. So that's what you'll see at night. Now, the June torrids are notorious for not being seen because they are between the earth and the sun for a good part of the period. Now, in other countries, you see more of the June ones. But, again, because the satellites are blinded, and so are we, because when you're looking into the sun, that's where the most asteroids come that are not detected, simply because you can't see them. But, guys, I talked about doing this video, so I guess the main point was that this June, coming up, the Taurid Betas, we're going to be going through a much denser field of rocks. And again, they go from the asteroid that was almost a mile wide down to 160-foot rocks like Tunguska. We're watching it, guys. It's a heads up. Be safe.